So this is fundamental theorem of calculus questions. And what we get is, in case A, 5x plus c, but we don't do the plus c. And we double check 5x, take the derivative, you get 5. Great. And what this means is we're going to take x and replace it with 3. We're going to take x and replace it with 1. Subtract. So the answer to question A is 10. There we go. If we remember, the fundamental theorem says from A to B is from B to A. I wrote it backwards, so actually f of A minus f of B. It's the upper limit minus the lower limit evaluated. F evaluated at the upper limit minus f evaluated at the lower limit. Okay. Next one. All right. So e to something, you just write down the function and then you say, now what? Well, if I were taking the derivative, I'd multiply by minus 0.2. So I must have, but negative. So I must divide by minus 0.2, but negative. Okay, so first step is right. It's a mess, right? But who cares? Just write it down and worry about it later. So if that minus sign in the denominator bothers you, you can get rid of it by the following stunt. This is not necessary, but if it helps you feel better, do it. If you flip the limits of integration, you're just flipping the order in which you're doing the, here, if you say like 7 minus 3 is equal to 4 and you flip the order of the subtraction, you're saying 3 minus 7 equals negative 4. So whenever you flip two items in a subtraction problem, you introduce or get rid of a negative. So that's all we're doing. Alright, so let's see. Divided by 0.2 is like times 5. So we have e to the 0 minus e to the minus 0.2. E to the 0 is 1. And then this negative sign here turns into this fraction bar, e to the 0.2. It's actually the 5th root. You don't have to do all these steps. Okay, I'm just doing it to be complete. Right? Part C. This one is not bad. Okay, so if we take the derivative of our result, do we get back to the problem we started with? So sure, take the derivative, the 3 comes down front, the 3 becomes a 2, yep, the 3's cancel out, y squared, yep, that piece works. Let's see, bring the 5 down front, then it cancels with the 5 on the bottom, y to the 4th, yep. Ooh, problem, this is supposed to be a plus. See, I found my mistake by trying to take the derivative and get back to my problem. Good job. Okay, see, so you guys too can avoid errors that way. And we don't have to worry about the lower limit because by the magic of, if you put 0 in for y, then in this case it doesn't matter because it's 0 plus 0. So we lucked out. We saved ourselves some work. D is, we're going to have to use u substitution, or we're going to have to use our special trick. So if we were to let minus t cubed be u, what's the derivative? Well, it'd be minus 3t squared. Do we have a minus 3t squared? No, but we can if we just multiply the inside of the integral by minus 3 and the outside by minus 1/3, then we've got it. Okay? So our integral is really just going to be e to the junk, right? So the minus 1/3 comes along for the ride now, and then we just have e to the junk, evaluated at 2 and minus 2. Okay, so what happens next? So you have minus 1/3. We could do that trick by flipping the limits of integration again, but I'm not going to do it twice. No, you can do it if you want to. Alright, and then we say minus e to the minus -8. So it becomes a plus 8. Alright, okay, I lied. I am going to do it, but now I'm going to do it after the fact. Okay. It's just kind of an obnoxious problem, but it's not that hard once you do it. So, where are the answers? This is the answer for part B. For part C. And for part D. Okay, hope that's helpful.